Good morning, everyone. My name is Hemu, and today we are here for our Palo Alto training. And today, this is our first day. So in day one and day two, I am going to cover these 7 topics. Like what is firewalls? I will go through with what is firewall because some of the people they are from the routing background and all right. Then we will discuss the stateful inspection because this was the technique or technology or mechanism which is developed by the engineers in 1994, and after that it has completely changed the inspection behavior of a device or of a firewall. So we'll discuss what is stateful inspection. Then I will go through with the Palo Alto firewall history, then Palo Alto firewall operating system, Palo Alto firewall hardware appliances, and Palo Alto firewall VM series appliances. Then we will discuss SP3, single pass software and parallel processing hardware. And this is the most asked interview question. If you are going for the interview, they will ask what is SP3? What is the architecture of Palo Alto? Can you explain single pass software and parallel processing hardware architecture of Palo Alto, right? So you have to know SP3. Then I will discuss the packet flow, and packet flow is another minimum 2 hours of session. When we will discuss everything on packet flow. Then I will tell you how you can get the initial access of your firewall. Whenever you will receive a new box, how you can basically get the access. What are the default parameters, sublevels, so everything I will cover with regards to this initial access. Okay. Now, let me start with what is firewall. So guys, a firewall is a software and hardware based network security system. Means a device called firewall. It is a hardware box and it may be a software as well, or it may be a virtual box as well. Okay, means your firewall generally a hardware appliance, which is a physical box. It may be a virtual appliance and it may be also software. Like guys, if you were heard the name of couple of antivirus softwares in your laptop, like in Windows, we have a Windows Defender, right? We have a McAfee, Norton, right? Quick Heal. These are the example of software based firewall. Even though, let me also show you one more software based firewall. If you will go into your Windows and if you will type here firewall.cpl, click on advanced settings, you have these inbound rules and outbound rules. Guys, anyone have any idea about these rules? Why we have these rules on your laptop, on your Windows machine? We are having these rules so they will control what type of traffic is allowed from your system, or who can basically send the traffic towards your system, towards this particular Windows machine. And if you will check here on my inbound rule, see, I have blocked all the HTTPS connection, block ping, right? Why I have done that particular, why I have created this rule? What this rule is doing, it is, I have put the name block ping, but I am allowing this particular connection. And just for the testing purpose, guys, what I am doing, let me just log in. I see you can use any terminal for that. Okay, there is no any hard and fast rule. Let me just run one simple command on the firewall just for the example. So I don't have any interfaces on my firewall. So 1 minute. Let me start my Kali Linux actually. So we will test this thing like software based firewall. Okay. So it will build some type of mindset actually. So it is just booting up. And meanwhile, if I'll go here and if I will type ncpa.cpl, it will basically open the network sharing center of my system. And I'm using Ethernet connection. And if I'll go on my Ethernet connection, and if you will check, the IP address of my system is 192.168.1.13, right? This is the IP address of my laptop. Now if I'll go on my Kali Linux machine, it is just coming up here. And guys, I will use this Kali Linux as well for launching couple of attacks during your training, okay? So you will get some idea about that as well. So if I will just open the terminal here, and if I'll just hit the ping to 192.168.1.13 my laptop, ping is working, right? And if I'll go on my laptop machine, I have this block ping, right? If I'll go here, and if I'll just select here, block the connection, if I click on OK, click on apply, now what will happen? Ping to my laptop is stopped working, right? If I'll just press Control C, if I again do the ping, see ping is not working. But if I'll go here, and if I'll just open this rule again, and if I'll just allow the connection, if I will allow, click on allow connection, it will allow connection from all the machines, anyone can ping, and you can see ping has started working. So guys, this is the best example of your software firewall. I hope you got the point, right? We have a firewall software based as well. Okay, so this is the just an example. Okay, now we go back. So guys, anyone has basically work on the Linux? In Linux, in Linux we have a IP tables. Like in Windows, we have a Windows Defender, right? In Linux, we have a IP tables, and we can also use these IP tables, okay, to restrict the communication on Linux machine. So these are the IP tables or your Windows Defender. These are the example of your software based firewall. Yeah, Burak, I will come on the stateful or stateless behavior. Okay, now. So a firewall is a software or hardware based network security systems that controls incoming and outgoing network traffic. Now, what do you mean by the incoming and outgoing traffic? Now let's try to understand what is incoming and what is outgoing. Let's take an example. This is my firewall. Okay, this is my firewall. This area is my LAN area, local area network, and let's say this area is WAN, which is wide area network or internet. Okay, now let's take an example. This interface of firewall is Ethernet 1x1. Let me use some different color here. This interface Ethernet 1x1, and this interface Ethernet 1x2. Now, let's suppose from this PC, I've initiated traffic towards this PC. I have initiated the traffic towards this PC. So it will basically send this traffic through your firewall. Firewall receive this traffic, it will process, it will exit, it will send out this traffic towards this system, right? This was the traffic flow. Now, to understand the incoming and outgoing, guys, incoming traffic means, or let me just give you the idea what outgoing traffic means. The traffic who is leaving your network means this particular traffic, because this is this area till here. This is your area, right? This is your company area. And outside of this area, here we have an internet, right? And over the internet, do you have any type of control? No, we are not having any type of control, right? So whenever your traffic is going out towards the internet is known as outgoing traffic. And whenever this particular, let's take an example, this particular PC, he has replied. Now when this reply is coming, so you know this particular traffic is coming towards your network, right? This type of traffic is known as incoming traffic. Means outgoing traffic, the traffic who is leaving your organization. Incoming traffic means the traffic which is coming towards your organization. And what firewall will do? It will control the traffic. Now, how it will going to control that traffic? What it uses for controlling the traffic. Now, let's try to understand that part. Okay. So just give me 1 second. I'm just going back here. Let me just open the same PPT on my browser as well here, because I will draw some drawing on my on this one. Okay, so you will get the whole idea. Yeah. Now guys, let's try to understand. So let's take an example. I have my users here. These are my LAN users. Okay. Then I have here my switch. These LAN users, they have a connectivity via this switch. Let's take an example. This is PC1. This is PC2. This PC have IP address 10.1.1.100, and another PC have IP address 10.1.1.200. Now this switch have a connectivity with the firewall. Let's take an example. This is my Palo Alto Firewall. Then this firewall has a connectivity with the internet service provider, which is ISP. And this interface is Ethernet 1x1, and this interface is Ethernet 1x2. So this interface is a part of my inside zone, and this interface is a part of my outside zone or untrust zone. Okay, I will come on that again. Now over the internet, I have, let's suppose, this particular server. Let's say this server belongs to facebook.com, and this server hosting the service on TCP port 443, and the IP address of this server is 151.100.100, just for example. Okay, now this is the network diagram I am having right now, guys. Now let's try to understand the things here. So if basically, let's suppose now on this PC, I've opened the web browser and I have typed facebook.com. So what this PC will do? This PC initiate the traffic, it will reach to the switch will forward towards the firewall. The firewall do the inspection, it will forward towards the facebook.com, right? Now when this traffic received by the Facebook, now what Facebook will do? It will basically reply. So let's take an example. It has sent the reply come to your internet service provider, it hit to your firewall, then to switch, and from switch to this PC. Now guys, whatever you are seeing with the green color here, this particular green color traffic is denoting the outgoing traffic, the traffic who is leaving your organization boundary, because your organization has a control till this line, right? This is your organization. These are the devices on which you have control, right? Do you have any control on the ISP routers? No, we don't have, right? They will not give you the access of their routers. We don't have any control over the Facebook, right? So the traffic who is leaving your organization is known as outgoing traffic, and the traffic which is coming towards your organization is known as incoming traffic. So I hope these 2 points are clear. Write yes, no in the chat if this is clear. Incoming and outgoing. Okay, that's great. Now, if you know incoming and outgoing, now there are 2 more terms you have to know. We have to know what is ingress interface. What is egress interface? Now tell me one thing, guys. Let's take an example. Let's suppose from this PC, I've initiated the traffic towards facebook.com. So this PC has forwarded the request like this, hits to the firewall, and it is going to till the Facebook. Now, guys, for this particular traffic, your Ethernet 1x2 interface become the ingress interface. Why this interface become the ingress interface means because whenever traffic coming and whenever it is entering towards your firewall through whatever port or whatever interface, that interface is known as ingress interface. And your firewall is exiting out this traffic because whenever your firewall receive any traffic, it will not hold. It will just process the packet. Either it will allow or either it will deny, right? What it will do, it will basically send out this traffic towards the Facebook via Ethernet 1x interface, and Ethernet 1x1 become the egress interface. So ingress interface is the interface which receives the traffic, and egress interface is the interface which exit out the traffic from your device. So I hope these 2 things is clear. What is ingress and what is egress? This is clear to everyone. Guys, any doubt on that? Just write on the chat if anyone have not understood. I think I got all yes, which is good. Now, as on this particular line, if you will see here, they have mentioned a firewall is a software and hardware based network security systems that controls the incoming and outgoing traffic. Means it controls the incoming and outgoing, right? So let's take an example. Let me draw some more thing here. Let's take an example. We do have one more interface on my Palo Alto firewall, and let me draw with the green color here. This is my Ethernet 1x3, and this interface is a part of DMZ zone, and here I have my servers. These are my internet facing servers. I will tell you what is the DMZ. Let's say, take an example. I have my web servers here. Okay. Now, these web server, let's suppose having the IP address 10.2.2.100 and 10.2.2.101. This is server 1. This is server 2. Now, over the internet, I do have one more user here. This is the internet user. And that user having IP, let's suppose 100.1.1.1. Okay. Now guys, as I have mentioned, like your firewall, basically what it used to do, it will control the incoming and outgoing traffic. Control means either it will allow the traffic or either it will block the traffic or it will deny the traffic, right? Either it will allow, either it will deny. Now, on which behalf basically it will allow or it will deny? Right? On which behalf it will allow, it will deny? Right? Because it's a machine, right? It needs some details. So it will basically allow or it will deny the traffic on the basis of rules or policies or ACLs, access control list. Right? Now, what is the exact information it is having into these rules? So your firewall, what it will do? It will allow, it will deny the traffic on the basis of layer 2 information, layer 3 information, layer 4 information, and layer 7 information. What do you mean by the layer 2, layer 3, layer 4, and layer 7? Are you aware about the TCP IP models or OSI model? Or the TCP IP model? Now tell me one thing, guys. Let me just take a very, very basic example who don't know what is OSI model, what is TCP model or TCP IP model. Guys, in every country, let's take an example, has somebody has done some type of like he did some type of bad stuff basically. Maybe he basically he has just stolen something from somebody, or maybe he has killed somebody, right? On which behalf basically basically we will judge the peoples, or the officers basically they will judge that particular person on the basis of some type of guidelines, some type of rules and regulations, or some type of law, right? We have articles. So the thing is, this TCP IP or OSI model have the same information. What they have content, they are having the standards or the statements which tells how two computers will communicate, how these two computers can communicate. To allow the communication between two systems, what we have to do, vendor of this computer and vendor of this computer, they have to follow the standards defined in TCP IP model, and they will do the programming according to that. And this TCP IP model, they have a layer 2. At layer 2, we have a source MAC and we have a destination MAC. At layer 3, we have a source IP and we have a destination IP. At layer 4, we have a source port and we have a destination port. At layer 7, we have a raw data. Right? Means what this firewall will do, this firewall is capable of reading the layer 2 information. It can read the layer 3 information, it can read the layer 4 information, it can read the layer 7 information. And what it will do, after reading the information, basically what it will do, it will control the traffic. Either it will deny the traffic or either it will allow the traffic, right? Okay, so we were discussing what firewall used to do. It used to allow, or either it used to deny the traffic, right? Or it used to control the incoming and outgoing traffic. Means incoming traffic, the traffic which is coming towards your organization, and outgoing means traffic going out of your organization, right? And what it will do, firewall used to control. How it will control? Because on the firewall, we used to basically write the security policies. Or if somebody don't know what is security policy, they might know access control list. On the routers or switches, if you want to allow the traffic, or if you want to deny the traffic, what we can write the access control list. And what we have into your security policy and ACLs, access control list or security policies, it is a combination of multiple statements. And what are these statements? What we used to define, we used to define if traffic coming from 10.1.1.100, and if this traffic going towards 150.1.100.100 on port number 443, you can allow or you can deny, right? This is how we used to form the access control list or the security policies. We used to define, right? We used to define in the source field, we will define the source details. In the destination field, we will define the destination details. And we will also define the source port or destination port field, right? Means my firewall, what it will do, it will use the layer 2 information, layer 3 information, and layer 4 information for allowing the traffic or denying the traffic. Means it needed this layer 2, layer 3, and layer 4 information for controlling the traffic. Now I hope you got the point here, how firewall used to basically control the traffic. I hope guys this is clear. I am not putting much here with the layer 7. Let's try to understand first legacy firewalls. How legacy firewall used to do the task, because at layer 7 we have a lots of discussion on what is next generation firewall and what is legacy firewalls. Yes, Bena, you can write your question on the chat. And I hope everyone got the idea here, how my firewall used to allow or deny the traffic, what information it uses. So I got one question from Binay. He has asked, layer 2 is a, at layer 2 we have a MAC address, we have a source MAC and destination MAC, right? So you know, Binay, we can also deploy firewall as a layer 2 firewall, and we can define the ether type ACLs. Okay, ether type access control list. Like in Cisco SA firewall, if somebody has worked, we can deploy on the transparent mode. Your Palo Alto Firewall also we can deploy as a layer 2 mode, and at that time it will act as a layer 2 switch. It act like a layer 2 switch. Okay. Now let me go back to that statements again. So a firewall is a network and hardware based network security systems that control incoming and outgoing network traffic by analyzing the data packets and determine whether they should be allowed through or not based on the rule set. So what is this rule set? Rule set is the access control list. What is packet actually? What is packet, guys? Anil, I take your question. Okay. At the end, I'm going to discuss this next generation firewall and legacy firewall, so you will get the idea on that. Don't worry. Now let me just tell you what is packet. So generally what happens basically, do you know how generally data is created? So you know, on your data we have a layer 7 information. Then this layer 7 information wrapped inside the TCP, and TCP generally wrapped inside your IPv4 header, and this IPv4 header is encapsulated inside the Ethernet header, and this Ethernet header is encapsulated inside the frames, right? This is how the wrapping happens. And you know, your entire information starting from this IPv4 till layer 7, this is known as packet. You can also share like layer 2 information also as a packet. But generally with layer 2 information, it is known as frame. So packet is your layer 3 header, which is your IPv4 header or IP header, then your TCP header or UDP header, and the layer 7 information. Okay. So what it used to, it will analyze the data. Packets means what it will do, analyze the data packet means it will analyze your layer 2 information, layer 3 information, layer 4 information, right? And I'm not putting here layer 2 much because generally we used to deploy firewalls as a layer 3 device. So layer 3, at layer 3 what? It will basically analyze, or it will get the information of source IP, destination IP, and layer 3 protocol number. At layer 4, it will focus on source port and destination port field. It will check that particular data, and what it will do, it will make the decision. It needs to allow the traffic or it needs to deny the traffic based on the configured access control list or the security policies. So I think the definition of firewall is clear. And guys, how the parsing happens, that's the discussion of your packet flow. How it will do the layer 2 parsing, layer 3 parsing, everything I will cover. Don't worry on that. Okay. Whatever I have discussed just to explain you what is firewall. And I hope now you will understood the what definition of the firewall. How it is doing the parsing, how it will read the layer 2 information, and how it looks like. That's the discussion of your packet flow. And let me just show you one information just for the knowledge purpose. So you will get the whole idea. Okay. How I will basically give you that details. Just give me 1 second. I'm just opening one of the. So, you know, when I will discuss your packet flow, I will tell you how Palo Alto Firewall going to process the TCP SYN packet, how it has start reading the information, because these are the live logs I have taken from the Palo Alto. How it is reading your layer 2 header, then layer 3 header, which is IP header, and how it is reading your TCP header. Okay. So it's a part of your parsing, and I'm going to cover how it is analyzing the TCP options, right? Okay. So that I will discuss later, but I hope this is clear now. Definition of the firewall. It is clear to everyone? If yes, then write on the chat. Okay, cool. Now, a firewall establishes a barrier between a trusted network or a secure internet network and the another network, which is internet, that is not assumed to be a secure or trusted network. Means what firewall generally used to do. This area is known as LAN area, right? Local area network. And whatever the users are available here, we have a trust on these users because these computers basically have a security postures at per your organization, right? You are managing all these particular computers using the domain controller. Do you know what is domain controller, guys? Or AD server, Active Directory servers? Because all your computers is managed and controlled by the domain controllers in an organization. They used to basically configure the group policies, and that is the main reason you are not allowed to install the unnecessary softwares, right? You will have lots of restrictions on them because these computers controlled by you and you have a full trust on them. So this area known as local area network. Do you have any trust on the WAN over the internet? Because in over the internet we have good users as well who is over in the internet for doing some business, and we have a bad users as well. Bad users, so I can say hackers. And what is the main intention of these hackers? Hackers always try to steal your information. They will always try to harm your system, harm your infrastructure. So on the basis of these particular parameters, in the firewall domains, we have some type of areas, like a area which is inside or trust. Inside or trust, let me write down here, inside zone or trust zone or land zone. And always, let's take an example, this interface, let's say this Ethernet 1/2, then I will put my interface Ethernet 1/2 into this particular zone. It is just the name, because we will use these zones on my security policies. Okay, and with the name, this inside zone, which means this is the most secure area, most trusted area. Why we are trusting on that area? Because this area controlled by our organization, and whatever peoples are there, whatever computers are there, these computers are designed and configured as per our organization policies, and we have a full trust on them. So these type of areas, or this particular area where we have these type of people, we will always put in a inside zone or either in a trust zone. The area or the interface of your firewall who connect you with the internet, that particular interface we will always put in a zone called outside or in a zone called untrust or a zone called internet or a zone called WAN. Why we have these type of names? Because this is the area where we will not trust on anyone, because in internet we don't have any trust. Maybe the person, maybe whatever the persons are available here, maybe he is an attacker, maybe he can basically harm your computer, harm your system, right? So that's why this particular area is known as a part of outside zone or either part of untrust zone or internet zone or WAN zone. Now you may ask why we have a different type of names, why we are not limiting our discussion till inside and outside. So guys, this inside and outside, it's a Cisco terminology. Who is Cisco? Cisco is also a firewall vendor. And your trust and untrust, it's a terminology from the Palo Alto. Okay. So because here we are discussing the general information of Palo Alto or general information of the firewall, so that's why I have covered. Like if you will see inside or trust, do not worry about it. Means you have to know, oh, this is the area where I have my LAN users. Outside and trust means we have to know, oh, this is the area where my firewall is connecting with the internet. So what firewall is doing? Firewall basically establish a barrier, or I can say it's a wall between a trusted zone and the untrusted zone. And here, what it will do, if any of the users from untrusted zone try to communicate with the trusted user, firewall going to block that connection right away until we will allow. Now you may ask why we need to allow the traffic from outside towards the inside. And so from outside to inside, we never allow. From outside to inside, we never allowed that traffic. And because we will never allow that traffic from outside to inside, that is the main reason we have basically invented one more zone is known as DMZ, demilitarized zone. What this zone basically used to do, if you will go here, in this particular zone, I always kept my web servers or the internet facing servers. Now you may ask why we have to basically put these type of server, because let's take an example. Your organization is a company A and you are dealing with some type of e-commerce business. Let's take an example. You are selling some sports goods. And now let's take an example. This particular user wants to purchase some type of sports articles from your website. What they will do? He needs to access your website, right? So what he will do? He will basically send that request into your firewall, and your firewall will forward this request over this web server, and this web server will reply with the content. So in these type of scenarios, we need to also allow the traffic from firewall from internet towards the type of servers, towards these your internet facing servers, towards your web servers. So now you got the point here why we need to allow the communication from internet towards your servers or towards your LAN area. It's not exactly LAN, it's a DMZ, towards your DMZ, right? Now you may ask why we have not kept all these servers inside this inside zone only. So for an example, let's take an example. Both of these interfaces are part of inside zone. This is just for example. Okay. And through this firewall, we have allowed the access of these servers towards this particular internet user, because this user wants to do some type of business with us. And on the inside, we do have these particular computers. And rather than they are connecting like this, let's take an example. These servers, they have connected from this switch like that. And let's take an example on this particular web server. We are having one type of vulnerability. There is a one vulnerability available into this particular web server. Let's take an example. It is having cross-site scripting vulnerability. Means this server, this web server is basically have this type of vulnerability. Somebody can launch the cross-site scripting attack, or maybe this particular server have some type of PHP vulnerability, or the web server rendering vulnerability. And because it is having that vulnerability, so what this particular internet user, let's take an example. Now this internet user is some type of hacker, and what he is doing now basically he has basically tried to he had just exploit this vulnerability on this server, and he just gained the unauthorized access of this server. Now he has a full control on this server. Now what he has done, because he has a full control of this server, he got the CLI access of this server. So what he has done, now he has basically introduced, he has just copied one of the malware into this server, and he has now tried to send this particular malware towards these computers. And there is a high chance now this particular malware is doing the lateral movement, or maybe after gaining the access of this server, now maybe he's trying to exploit, he will try to check if these particular computers or the user systems is also vulnerable for any vulnerability. Then he will may try to exploit these particular vulnerability as well. And here for this type of this type of attack, we are not having any type of control, because it's just a switch. From this server, we can move our attack towards these PC easily, right? We can do the pivoting and double pivoting type of attacks as well. It is possible, guys, or not? Lateral movement of your attack is possible in this situation, because we have your computers and we have your public internet facing servers into the same zone. So it is totally possible, right? Now, what is the solution for this? So to avoid such type of problems, what they have done, they have created a dedicated zone called DMZ. And they have a dedicated zone called inside, and in inside zone we have our actual users, actual computers. If one of our server is exploited here, then and if that attack now trying to move towards your PC board, he has to send that request towards the firewall, and now through this firewall this request go towards your PC. But here we will put the restriction. If any of the server trying to reach these computers, what we will block that traffic right away, because we have that type of rule on the firewall. And by default, firewall will not allow any type of traffic from inside or DMZ zone. They will not allow, means inter-zone communication is not allowed on the firewall. And what is inter-zone communication? Means communication happening between two zones, and we will discuss that details in depth in your security policies, because we have a two rules on the firewall: intra-zone default rule and inter-zone default rule. Okay, so now at least now I have now, I am not able to save my servers, but I have saved my actual users, right? So that is the reason we used to introduce the demilitarized zone or DMZ zone. Now, tell me one thing. So guys, DMZ is a zone where peoples from internet, they will also reach and they will access the web content, and your inside users will also access these servers. So now you can ask why in these PC1 or PC2 needs to access these servers. Let's take an example. PC1 and PC2 hold by the network administrator, network admin. And now this network admin wants to update the web content on this particular servers. So what he will do, he will access these servers via SHS, and people from internet, they will access these servers over TCP port 80 or either on TCP port 443, like your HTTP traffic or either HTTPS traffic, right? So you can say DMZ or demilitarized zone is a less secure zone in comparison to outside, but it is more secure in comparison to outside zone, but it is less secure in comparison to inside zone. So means it is a middle security zone or the balanced security zone. I hope now these points is clear to everyone: outside, inside, and DMZ. If yes, then write on the chat if you got the points here. And I hope you have a now clear understanding why we use demilitarized zone. Okay, that's great then. So now this covers this particular, what is firewall? So as I have mentioned, what firewall used to do, firewall generally allowed the good traffic and it will basically block the bad traffic. This is also one of the more responsibility of the firewall. If I will tell you couple of vendors for the firewalls, so we have a Sonic Wall, Palo Alto, Juniper, Cisco, Checkpoint, Stonesoft, Fortinet, WatchGuard. There is a hell lot of vendors are there, and I will mention what are the vendors who has a very good market cap. Now let's try to understand the stateful inspection, guys. Very, very good topic. And in your interviews, they will ask what is stateful inspection. Sumant, regarding this cross-site scripting attacks, you can basically search over the internet. You will get lots of articles. And even though in your vulnerability session, when we will discuss the vulnerability protection, I will launch this cross-site scripting attack on the Amazon website. Okay. Now, now let's try to understand the stateful inspection. So, before stateful inspection, let me just tell you what is the stateless behavior of the firewalls. So guys, For simplicity, I'm just removing this DMZ part here from here. Now we are discussing most important part, guys. Let me remove this internet user as well, not required at all. One user is enough. Okay. Now let's take an example. We have this type of setup. But instead of firewall, let's take an example. We have a router. This is my router now. This is a router I'm having. Siraj, so you can ask that DMZ question after when in your in the Q&A session. Okay. Now let me just move further towards the stateful inspection. So guys, anyone have worked with the Cisco routers? And in your routers, if you want to allow or if you want to deny the traffic, what will happen? We used to write the access control list, right? By using access control list, we used to allow the traffic and we used to deny the traffic. Now, let's take an example, guys. We have a facebook.com which is hosted on TCP 443. IP address is 151.100.100. And now on this particular page, let's suppose, or let me instead of facebook.com, let's take an example of journal server actually. Journal server will help you. Let's take an example. We have a server 100 over the internet, and on that server what I am having a file of 2 GB. It's a .mp4 file, and now I want to download this particular file from this server 100 on this PC. So what this PC will do now? So guys, now on this PC I will open the web browser and I'll just type https 151.100.100 this IP. What is the first packet this particular PC will initiate towards this server? The very first packet is TCP send because it's that server hosting or TCP, right? In TCP, what will happen? First TCP three-way handshake will happen, and once TCP three-way handshake will complete, what it will start the your SSL handshake, and once SSL handshake will complete, then what it will do? And after that, it will start with the normal communication. It will start downloading this particular file, right? It has sent the TCP send, and guys, for just for the simplicity, let's take an example. It's a web server, okay? Because I don't want to go in the SSL right now until you will got the idea. So let's take an example. It has sent TCP send request towards the router. Now what router used to do? When router received this packet, so it will receive this packet at Ethernet 1 by 2, right? So it will put this packet into the ingress processing. It will increase the interface counter by 1, right? And it will basically check the routing, it will check the net, it will check the access control list. If we have a policy based routing, then it will check the PVR policies, it will check the SEP policies, right? And it will check the SEP table, and after that it will do the ARP lookup and all, and after that only it will do the, it will basically exit out this particular traffic through Ethernet 1 by 1 interface, right? So router has exited out this traffic towards this server. And when this router do the processing, what it used to do, in case of Cisco routers, they have around 27 checks. They have around 27 checks if we will use all the features of a router. And the main checks, on this router is the routing lookup, your net lookup, your access control list. These are the main checks. Out of these 27 checks, let's take an example. If router needed around 2 seconds of time, hypothetically, to process this particular entire TCP SYN request, then routing, net and ACL checks, they need entire 1 second. Now this packet reached to the server. Now what server will do? Server will reply. What we will receive in the reply? TCP SYN plus ECK? Yes, no. We will get the TCP SYN plus ECK packet. Now again, this router basically do these 27 checks. Again, it needs a 2 seconds where routing, net and ACL, it needed around 1 second. And after that, it will basically sends the acknowledgement. This is the ACK request. This ACK request again go through with these 27 checks, right? And once they will complete this TCP three-way handshake, what will happen? Now TCP connection is in established state. And now what they will do now, it will basically sends the HTTP GET request. HTTP GET will also go through all these 27 checks. Then he will get the reply. HTTP GET request, HTTP response. And like that, they do the communication, right? Multiple HTTP request and response you will see until you will download this entire 2 GB of file. Let's take an example. Between this PC and this particular server, they have basically exchanged 200 total request and reply packets. Means all these packets, they have exchanged around 200 packets. So if this router, when this PC has downloaded this 2 GB of file, why this router? How many seconds is needed to process this entire communication? Around 400 seconds. Because each and every request needs to go through with the 27 checks. Okay. So this is the behavior with regards to the router, and router is a stateless device. Router is a stateless device. So with regards to this router, guys, this process is clear. Any doubt on this process? Now let me just tell you what is the behavior with regards to the stateful. Now we have a same type of setup. We have a same PC here. 10.1.1.100. Now I'm just putting the firewall directly. Ethernet 1x2. It's a part of inside. We have an internet. This is Ethernet 1x1. This is a part of outside zone. Internet service provider. And here I have a same server. Server 100. That server 100 IP address is 150. 1.1.100. It is running on TC port 80 and it is having the same 2 GB of file. And guys, if somebody wants to understand what are these 27 checks on the router, read these particular documents of a router, because I'm not an expert on routing. I am a hardcore security guy. Read the Cisco documents, you will get 2 GB of file. Now guys, we have this setup. Now here you have to put your full attention, okay, because this is most important. An entire batch, basically all your classes has a dependency on this communication now. So I will request, put your full attention here on this particular discussion, because here we are discussing so many things. Now this particular PC has sent one request, which is a TCP SYN request. And guys, let's take an example. It's a Palo Alto Firewall. Okay, because I'm discussing with regards to PA firewall. It will send TCP SYN request. Now firewall do the processing of this particular SYN request, and once it will do the processing, it will forward this particular request towards this server. Now when firewall receive this particular packet on Ethernet 1x2 interface, what it will do? It will start the processing. And how it will do the processing? The very first thing which is done by the firewall is, what it will do? It will basically process the packet at ingress stage. The second thing which is done by the firewall is flow lookup. Third thing, session setup or silo path. Then fast path, and fifth one is, so guys, I'm just putting, it will also use to perform the app ID, content ID, and seventh one is forwarding. Forwarding is also known as egress stage. That's how your firewall or Palo Alto Firewall used to do the packet processing. And this is the 7 stages of your packet Palo Alto packet flow. Ingress stage, flow lookup, silo path or session setup state, fast path, app ID, content ID, and egress stage of forwarding stage. Now, guys, just remember one thing. I'm just highlighting this detail, okay? Because in TCP SYN packet, it is not having any type of layer 7 data. So because you know app ID and content ID is only processing your layer 7 information from the packet, and your TCP SYN packet, it is not having any layer 7. So these two stages will be not there for your TCP SYN packet, just remember. And as of now, you just needs to know the stages: ingress stage, flow lookup, session setup or silo path, then fast path, and forwarding stage. Now, in the silo path stage, I am just putting here, in the silo path stage of Palo Alto, what it used to do, in the silo path, the major checks, which is routing table lookup, your net lookup, your security policy lookup, is done by the in the silo path only. Okay. And guys, just for the same example, this firewall, let's suppose it's take a 2 seconds. When your packet going through ingress stage, flow lookup, slow path, fast path, and forwarding stays. It's needed around 2 seconds of time. Okay. But what this firewall will also do, because your Palo Alto firewall is a stateful firewall. Your Palo Alto firewall is a stateful firewall, right? And what it used to do, all the stateful firewalls, they used to maintain the session information. They used to track the state of a connection or a state of a flow. Whenever this, because this PC is trying to communicate with this server, so for the entire communication, this firewall maintain a session. And how it will basically create a session, your Palo Alto firewall will create a session. So what it will do, because in TCP send request or on this particular packet, we have a layer 3 information, we have a layer 4 header, right? So what is the layer 3 information? From layer 3 header, what we will get? We will get the source IP address. What is the source IP here? 10.1.1.100. What is the destination IP address? Means your source IP, your destination IP, which is 150.1.1.100, which is destination IP. Then your layer 3 port number. What is the layer 3 protocol number for TCP? 6. Layer 3 protocol. At layer 4, we have a source port and destination port. So what it will do? Let's take an example. This PC has randomly chosen a port number, source which is 3050, and destination port is always fixed, which is 80. And we know this firewall know he had received the traffic on Ethernet 1x2 interface, and Ethernet 1x2 interface is a part of inside zone. So he will also include the source zone detail, which is inside. Means now these are the 6 tuple of your session table or the connection table or the state table. These are the 6 tuples: source IP, destination IP, layer 3 protocol number, source port, destination port, and source zone. My firewall basically remember this particular information for this particular communication, and it will maintain this particular details in a session. What it will maintain this detail in a session. And now guys, whatever request, now when this particular server, he will reply. So he will reply with TCP send plus ACK, and now he will basically sends the ACK. TCP acknowledgement packet, and after that they will exchange the HTTP related packets, right? HTTP request and HTTP response, right? You will see lots of packets here and there. Now what they used to do generally, now whenever my firewall receive a, now whenever my firewall receive any subsequent request packet or subsequent reply packet, so this is a reply packet and these are the request packet, then request reply, what it will do, it will bypass the slow path for subsequent request and reply. And why it is bypassing this particular slow path stage? And major checks available in the slow path only: routing, net, security policies. what it used to do, it will bypass these particular checks. Why it will bypass? Because it has created the session on the basis of source IP, destination IP, layer 3 protocol number, source port, destination port, and the source zone detail. It has created that particular session. And because it is bypassing the silo path for all these particular packets. And as I have mentioned, if my firewall, when firewall is processing the packet at ingress stage, flow lookup, silo path, fast path, app ID, content ID, and ingress stage, then it needs 2 seconds, where your silo path is taking 1 second out of these 2 seconds. And because we are bypassing this particular check for subsequent request and reply packets, and let's take an example, they have exchanged 200 packets, like they have exchanged in case of router. When they are downloading this 2 GB of file, what will happen now? To process these 200 packets, how many time taking by the firewall is 201 seconds only. Guys, this is clear. Don't worry about the stages. I know you will not able to understand the stages as of now, but when we will discuss packet flow, you will get the whole idea on it. So it will bypass your routing engine, routing table, net lookup, and security policies from the silo path, because it's a part of silo path. There are so many other things also available in the silo path. I have not discussed these things because we will discuss later when you will have the whole idea of each stages, how they used to do the packet processing. So at least, because on this firewall it's a stateful device and it is maintaining the state of a connection in a table called session table or the connection table or the state table. And what it will do, on that table it will store the source IP, source port, source IP, destination IP, layer 3 protocol number, source port, destination port, and the source zone details. Because it will store that information, it will identify all the subsequent request and reply packets on the basis of that information. And because my firewall know, oh, this request belongs to this session, so let's bypass the silo path. And whenever it will bypass the silo path, means it is saving the time. It is saving the time, right? Because these are the major checks which really needs time, because maybe you are having 10,000 policies, security policy in your firewall, maybe you are having 2,000 routes in your firewall, right? And they really needs time. So because of stateful inspection, we have reduced the, and we have completely changed the inspection behavior as well, because we have bypassed couple of checks which is not needed. Because once your security policy checks is passed for this flow, then we can bypass for the remaining communication, because their source IP and destination IP, source for destination for protocol number, and source zone will not going to change. And if it is not going to change, if we are allowing that traffic on the firewall, then every time whenever it will do the lookup on security policy, it will allow, right? So whether better we can just do the lookup once and we can bypass for the remaining communication. So here, your router took around 400 seconds for processing, but your firewall is taking only 201 second, means we have saved around 199 second. Means because of this stateful inspection, your firewall throughput just increased by double in comparison to your routers. Okay. So this is one of the analogy which I generally tried while explaining the stateful inspection. Now let's go here. Now let's try to understand. So guys, what generally your firewall used to do, or what is your stateful inspection? What in a stateful inspection, it checks your layer 3 and layer 4 information. At layer 3, source IP, destination IP, and layer 3 protocol number. Guys, what is the layer 3 protocol number for UDP? Write down on the chat if somebody is aware about that. What is the layer 3 protocol number for UDP? 17. What is the layer 3 protocol number for ESP packets? What is the layer 3 protocol number for GRE packets? And what is the layer 3 protocol number for ICMP? So Saruk, you have answered correctly. For ESP, it's 50. For GRE, it's 47. For ICMP, it's 1. And what is for AH? Anyone aware about this AH protocol? AH is 51. Okay. So we do have a lots of layer 3 protocols. Okay, just remember. Now, and the layer for information within an IP packet and store that information in a separate table referred as a state table of the firewall. So guys, if I'll say state table, if I'll say the session table, or if I'll say the connection table, all are similar. If I'll say session table, it's a Palo Alto terminology. Connection table, it's a Cisco terminology. If state table, it's a checkpoint terminology. Okay, so what it is checking layer 3 and layer 4 information from your IP packet, and it is storing that information into the session table. All the traffic flows through the firewall will be compared or inspected against the state table entries. Means whenever my firewall receive a packet, what it will do, it will basically extract the layer 3 information from the packet, layer 4 information from the packet, and it will basically match this layer 3 and layer 4 information from the state table. Means it will use to perform the session lookup or the connection lookup on the connection table. Because when it will do the lookup into the connection table or state table, then only it knows, right, this packet belongs to the existing connection, or this packet basically is a new request. It maintains the state of a connection when packet is traveling. For the appliance, a stateful firewall maintains the state of a connection in the state table of the firewall. After adding information in the state table, it forwards the packet to the destination. When it receives the reply packet, it matches the packet information to the state table. If firewall receive the reply packet, if match the packet is accepted, otherwise drop. What it used to do, now whenever it will receive, once it will create a session, right, so whatever request you, whatever reply you will get, or whatever request you will get, what it will do, it will match each and every packets against these requests and replies. And what it will do, it will basically bypass the slow path. It will bypass the slow path completely. Okay, just remember. So like that, it will write down the information. Okay, now let's try to understand few more details. A stateless firewall watch the network traffic and restrict or block the packet based on source IP, destination IP, source port, destination port, layer 3 protocol. A stateless firewall do not maintain the state of a connection or session. Like your ACLs on your Cisco routers is the example of a stateless firewall. Your Windows firewall, whatever we have discussed in the initial time, I have created one inbound rule, right? It is example of a stateless firewall. Access control list in your routers is an example of stateless firewalls. Okay, now, so guys, now let's try to understand one more thing. See, this particular stateful technology is developed in 1993, and this particular technology developed by the person called Nirzuk. He was a tech engineer on checkpoint. So the actual owner of that particular stateful inspection is the checkpoint firewalls. So checkpoint is the firewalls who has introduced a stateful inspection first time in 1993. And after 1993, in 1994 onwards, all the vendors like your Cisco, that time they have a Cisco ASA, your Juniper, all the other vendors, what they have done, they have basically deployed this stateful inspection techniques on their devices. So the actual owner or developer of this particular technique is Checkpoint, and the person who has done this is Nirzuk. Now, who is Nirzuk? He is a founder of Palo Alto Networks. So what he has done, initially he was a part of NetScreen, which is nowadays known as Juniper Networks. So initially he has worked with the Juniper Networks or NetScreen. Then he left NetScreen and he has worked in the Checkpoint. And after that he left Checkpoint and he has basically created his own firewall, which is Palo Alto Networks. So he has basically introduced Palo Alto Networks in 2002. He had launched this device in 2002, but that firewall have lots of bugs. It has lots of problems, so he has stopped, and now he has again done some R&D, upgraded the things, and then he has launched the Palo Alto Networks again in 2005. And when he has launched this Palo Alto firewall in 2005, Palo Alto is the first firewall who has a support of application ID, app ID feature, your content ID features. Means it has lots of very nice features within the box. Means it has lots of layer 7 features. And because it has these beautiful features, just within 3 years of time, in 2008, Palo Alto become the market leader in the firewall industry. And from 2008 till today, Palo Alto Firewall is the market leader, and he is leading the firewall industry since then. Okay, so this is the little bit history of your Palo Alto networks. And if you will basically type here Nirjuk, so you will get the idea. He is the person. You can basically get the details. Author at Palo Alto Networks and all, right? So you will get the whole lot of details with regards to that person. So he has worked with Checkpoint. Now he's a Palo Alto, right? He's in Palo Alto. Okay. Now, so if you will see this particular diagram, now let me come back here. So we have discussed this stateful inspection. Okay, so as I mentioned, when he has launched the Palo Alto firewall first time, it was the first firewall who has a support for app ID, application identification, user ID. You can able to implement the user based policies, and it has a support of content ID just within the one box. All these features you will get in the same box. And if you will check the Gartner report, you can see Palo Alto is the market leader. And after that, we have Fortinet, then we have Checkpoint, then we have Cisco. Okay.